So now let's start with the another most important topic, which is our cross product. Now what do we mean by cross product and what do we calculate using cross product? Basically, if we are given two vectors which are in a plane and they are of course co-initial, that means they are starting from the same initial point, we are trying to find out a vector which is perpendicular to both these vectors. So to find that perpendicular vector, we have to use cross product. Like for example, in this diagram, you can see that there is a point. Again, this is our co-initial point. From here, two vectors are coming out. One is our A and one is our B. Now the angle between these two vectors is theta. Now if you look at this diagram properly, it is in a 3D curve. So basically, if we say this is my Z axis, I can say that these two lines here is in my XY plane. So my, let's say my X plane would be somewhere here and my Y plane would be somewhere like this. So this is how my XY plane is looking like. So basically this is in my XY plane, or it can be any other plane. So just for the time being, we are considering it to be XY plane. Now we have to find out a vector which is perpendicular to both these vectors. So it can either be in this direction, which is our n vector, or it can be in this direction, which would become our minus n cap vector. N cap is nothing but a unit vector which defines the direction which is perpendicular to both these A and B vectors. So here A cross B, B, let's say this is our C vector. So that is how we can say that C vector is our cross product of A and B vector if it is perpendicular to both A and B. Now generally, how do we know which direction the perpendicular vector is going to be? Is it going to be up or is it going to be down? Now for example, here we are finding out A cross B. That means what we do is, there is a trick here to find out. We use the right hand thumb rule to find out the direction of our resultant vector. So what we do is, it is A cross B. So first what we do is, we try to put our right hand's palm on the A vector as if it is pointing towards the A vector, and we try to face the palm on the other side, which is towards the B vector. Let's say I hope you all can see my video right now. Let's say this is my A vector and this is my B vector. So what I do is, I put my right hand in the direction of A vector and my palm is facing towards the B vector. Now what I do is, now I look at my thumb. My thumb is pointing upwards. That means the cross product of these two vectors would be C vector. Again, that C vector's direction n cap is going to be upwards. Now let's say if I was to find out B cross A, and my B vector is here, my A vector is here. So what do? I keep my palm, right hand's palm, on the B vector and it is facing the A vector. Now I look at my thumb. My thumb is facing downwards. That means my n cap would be below. So that is why C vector is equals to A cross B. So this becomes our C vector, this one. Now let's say if I was to find out another vector, D vector, which is my B vector cross A vector. So this would become basically this vector. This would be my D vector, which can be written as minus of A vector cross B vector. So again, reminding you one thing, cross product gives us a vector quantity. The value that we are going to get is going to be a vector, and it is going to be perpendicular to both the vectors that have been provided to us. Now of course, how else can we write C vector? If I were to write it in the magnitude form or in the angle theta that I've written, it can be written as A vector modulus into B vector modulus sine theta into n cap, and n cap is basically my unit vector which defines the direction. So basically this is here to represent that this entire quantity here is a vector and not a scalar quantity. So n cap represents the direction. So keep this thing in mind. Now let's say if I was to find out the modulus of C vector, or which is basically I'm talking about my A vector cross B vector's modulus. Now if I'm talking about the modulus, then of course I would be taking the modulus of this entire quantity. And what would be the modulus of this entire quantity? Again, A vector modulus, B vector modulus sine theta. N cap, since it is a unit vector, so its modulus would become 1. So that is how we find out the magnitude and the values of cross product. Now let us talk about a few properties. Again, magnitude, as we discussed just now, this is the formula for finding out the magnitude. Direction is given by the right hand rule, as I mentioned. Let's read it out. If the fingers of your right hand point from A to B, then your thumb points in the direction of C. Like I told you, your palm should be facing the other vector to which you are finding the cross product, and your thumb basically would define the direction of your cross product or the C vector. Talking about the anti-commutative property, A cross B is equals to minus of B cross A. So A cross B is not equal to B cross A, of course, because B cross A gives us a vector which is in the opposite direction of A cross B. So definitely it comes out to be minus. You must remember this property. Apart from that, distributive property remains the same as we had studied in dot product and parallel vectors. Now let's say if I have two parallel vectors, they are not co-initial. That means it would be difficult for me to find any vector which is perpendicular to both of them and is co-initial to both of them. So A cross B for any parallel vectors becomes 0. And also you can look at this from the formula itself. A cross B, how do I write A cross B? A vector mod B vectors mod sine theta into n cap. And what if I put theta here to be 0 or 180 degree? Sine theta would become 0. That means this entire term becomes 0. So A cross B also becomes 0 for parallel lines. Now how can we find out the cross product for component form? Let's say A and B both have been given in the component form, A1 I cap, A2 J cap and A3 K cap, and B is given as B1 I cap, B2 J cap and B3 K cap. So to find out the cross product, what we do is A cross B, we take the determinant. Now we have studied this in our matrices and determinant, how we can find out determinants of any 3 cross 3 set that has been provided to us. So we write down the unit vectors at the top, and then let's say if I'm writing the A at the first letter of the cross product, so A's component would come first and then B's component would come out to here. Let's say if it had been B cross A, then I would have written B1, B2, B3 in the middle line and then A1, A2, A3 in the last line. So that is how determinants are represented. And again, calculating the determinant of this is very easy. We simply go for I cap, eliminating this line, A2 B3 minus A3 B2. Then we go for minus J cap, eliminating this line, A1 B3 minus A3 B1, and then K cap, again doing the same thing. So again, another important formula that you must remember about cross product. Now about cross product, let's talk about the specific unit vector rules. Let's say, of course, we know now that the cross product is going to be perpendicular to both the vectors that I'm trying to find the cross of. So I cross J, of course, I hope you understand that I is in the x-axis, J is in the y-axis. So what is going to be perpendicular to these two? Of course, it is going to be the k-axis which is perpendicular, or the z-axis we can say. So that is why I cross J comes out to be K. J cross K comes out to be I, K cross. Now, how can you remember this? There is a shortcut trick for you to remember this. Shortcut trick to remember this. Simply write I, J and K in a circle. Draw arrows towards I, J and then K. If you cross I cross J, you are going to get K cap. If you cross J cross K, you are going to get I cap. If you cross K cross I, you are going to get J cap. Now, let's say if I was to reverse this, what if I say that I am crossing J cross I, then I would get minus K cap. So basically, if I'm going against the direction of this arrow, then that means I will get my answer to be negative of that unit vector. Else, it's going to be positive. So J cross I would become minus K cap, I cross K would become minus J cap, and K cross J would become minus I cap. Again, all of these are caps, of course, because they are the unit vectors. So another important thing you must remember, you can just remember the shortcut trick, and based on this you will be able to solve your questions. Now again, the same thing has been mentioned here, anti-commutative property. Reversing the order gives us the reverse of it. Now the cross product of any unit vector with itself is always 0. I cross I would always give us 0, because of course the angle between them is 0. And if angle is 0, that means theta is 0, sine theta would become 0. So ultimately A cross B would come out to be 0. So I cross I is 0, J cross J is also 0, K cross K is also 0. Now, before we get into there, let me tell you about an important property that you must remember. Let's say I find out A vector cross B vector. Now, of course, this is going to be a vector that is perpendicular to A and B. Now, what if I say that, let's say this is my C vector. I'm assuming this to be my C vector. Now, what if I dot product C vector and A vector? What would I get? Now, you have to visualize this. I have my A and B vectors in this direction, and my C vector is going to be perpendicular to this. That means it is in this direction. Now, my A vector was here. Now, that means A and C are perpendicular. And what did we learn in dot product? If there are two vectors which are perpendicular, then the dot product would always be 0. That means what I'm saying is A vector cross B vector dot A vector would give me 0. And this would also be equal to A vector cross B vector if I dot product it with B vector. So that would also be 0. So you must remember this thing, how we are trying to visualize this entire thing. Now, this is just a formula which is used to show us the relation between cross product's magnitude and the dot product. So basically this is the formula, you must remember it. A vector cross B vector whole square plus A vector dot B vector. Now, this is our scalar quantity. We do not need to put any magnitude sign here. This wouldn't come out to be a magnitude. That is why we've applied the modulus sign, so that we get the magnitude of it, and that would be equal to A vector modulus square into B vector modulus square. So again, a relation that you must remember. So before we look into a question of cross product, let us first understand one thing. Let's say if I am given L, which is a scalar quantity, L into A vector, and I'm taking its cross product with let's say lambda into B vector. So now this is these two are my scalar quantities. Simply just scalar lambda and L are just scalar quantities. So what I can write this as, this can also be written as L into lambda outside and A vector cross B vector. So this is basically a scalar property of cross product that you must remember. Let's say if I have any scalar multiplied to any of the vectors, so it can be taken out of that vector. So you must remember this property as well. Now let's look into a question to get our concepts more clear about cross product. In this question, let A cap, B cap be unit vectors. If C vector is such that the angle between A cap and C vector is pi by 12 and B cap is this, then we have to find out the value of 6 C vector magnitude whole square. So first let us look at whatever the information has been provided to us. We've been given B cap is equal to C vector plus 2 times of C vector cross A cap. Now from here, one thing that you can see is that, let's say if I dot product, or if I square this, basically dot product this entire vector with itself, what would I get? B cap dot product with B cap would give me 1. C vector dot product with its C vector would give me C vector's modulus. So there can be something that I can get. And of course, since there is a cross product here, if I take the dot product with, let's say, some other vector or anything, there can be 0 that can be arised in that equation. So let us try to create that. So again, in the question they haven't given us any other information. So what we can do is we can simply dot product this entire equation with itself. So what I'm saying is B cap dot B cap. We are dot producting this entire equation with itself. So this becomes C vector plus 2 times of C vector cross A cap dot C vector plus 2 times of C vector cross A cap. Now let us try to solve this. Of course, B cap dot B cap would give us 1. It's a unit vector and the angle between them is 0 and cos 0 is 1, so 1. This can be equal to C vector dot C vector. So this will give us C vector whole square plus, now what about this one? What are we going to get from dot producting this and this? We are going to get 2 times of c vector cross a cap dot product c vector. Now you can see that c vector is getting crossed with some other vector, so there is, the answer is going to be a vector which is perpendicular to c vector, and then taking the dot product with it will give us 0. Plus, now what if we take the dot product of this c with this one? Again we are going to get the same thing, 0. Plus, now we have to square this term, we are going to get 4 times of c vector cross a cap dot c vector cross a cap. So this is basically what we are getting. Now this entire term, now since we are taking the dot product and it is the same quantity that we are taking, so this would become 1 is equals to c vector modulus square plus 4 times of c vector cross a cap whole square. So this is what we are getting. Now let us try to simplify this further. What we can get is 1 is equals to c vector whole square plus 4 times of, now this modulus of c vector cross a cap, this can be written as c vector modulus a cap modulus sine theta, the angle between them, this whole square, because of course we know, we had studied the magnitude of a vector cross b vector is a magnitude plus b into b magnitude into sine theta, and theta they have given us that the angle between a cap and c is pi by 12. That means theta can be taken as pi by 12. Now of course we would be getting sine pi by 12, and pi by 12 is nothing but 15 degree. Now of course we do not know what is the value of 15 degree directly, so what we can do is this would be converted into a square, so we would have sine square pi by 2. What we can say is 2 sine square theta would be equal to 1 minus cos 2 theta. I hope you all remember this. I hope you all remember this thing from from trigonometry that we had studied. So this property we had studied in trigonometry. So we can use this to find out our sine square theta. So let us use the formula. What do we get? 1 minus c vector whole square. This would be equal to 4 times of c vector modulus. A cap modulus would become 1 because of course a cap is a unit vector, and we would have, this would become square, sorry, and we would have here sine square pi by 2. Pi by 12. Now let us find out the value of sine square pi by 12. From here we can say that using our trigonometric values, we can say that 2 sine square pi by 12 would be equal to 1 minus cos pi by 6. We can write it in this way. So sine square pi by 12 would be basically equal to 1 minus cos pi by 6 upon 2. And what is cos pi by 6? Root 3 by 2. So this is 1, sorry, this would become 2 minus root 3 by 4 basically. So let us replace that value here. Again, it is in square. So let us take this to the other page. This would become 1 minus c vector modulus whole square. This would be equal to 4 and 4 would get cancelled. So we would be left with c vector modulus whole square times of 2 minus root 3. Now let us take the c vector together. So what do we get? 1 is equals to c vector modulus whole square. This would become 3 minus root 3. And from here what do we get? C vector modulus whole square is equal to 1 by 3 minus root 3. So we've gotten the value of c vector whole square, and we had to find out 6 c vector whole square. So we can write this down as 36 c vector modulus whole square. Of course, we had studied the scalar properties of magnitude of any vector. So what do we have to find? We have to find out 36 c vector whole square. So this would become 36 times of this would become 3 plus root 3. Just to simplify this, what we can do is I have multiplied 3 plus root 3 below and 3 plus root 3 above, so that we can remove the root sign which is below. So this would become 9 minus 3. Basically this would become 6. From here we can get this. So 6, 3 plus root 3, this becomes our answer. This was a question that was asked in one of the previous year JEE Mains. Now again, once you get going with the question is very simple for you to solve. However, the only hard part in this entire question was first to find out that we must have to take the dot product of this equation with itself.